Okay. Yeah, I think we have enough people to start. First of all, can you guys see the screen that I'm sharing?
Yes, we can.
Okay. How about now? Did it change to Spider?
Yes.
Okay. All right. Okay. All right. So I'll just turn on the camera for a few minutes and then we can focus more on the slides later on. My name is Humayun Hafeez Ahmed, and this is a very introductory course on programming, and we will be using Python as the language. For some of you, it might be boring in the beginning if you already know programming, but it will become very interesting and advanced as we move along. It is a very fast-paced course. I will go over the um, uh, sorry, I was just checking a message. Yeah, we'll go through as we go through the course. I will let you know the contents later on, but it will become very advanced very quickly in the next few sessions. We have problem sets as well. Although since this is not a university course, I would not be grading them, but you can work on them as we go along. At the end of this session, I will be releasing the first problem set, and that has a very basic problem that you can solve, and the information that we have from this session today should be enough for you to do that. All right, so this was little bit about the course. We will talk about what is meant by computation and how computers do it, and how can we relate it to our problem-solving activities. We will also go through some basics of the Python language. How does it work? What kind of operations it can do. There are some mathematical operations that we can do, and there are many other constructs that we will learn in the future sessions. For example, iterations and recursion that will be coming up in future sessions. We will talk about what are variables, what are different types, what are the different types of data types. There are some scalar objects and some non-scalar objects. What does that mean? We will look at that. The slides and code for each session will be provided to you a day before the session or in that morning. I strongly encourage you to download them, keep the slides with you if you have more than one screens. If not, then it's okay. You will be able to see them here during the lecture. But also download the code files for each lecture, as the examples that we will do will be included in that, and there will be more code that we will be writing as part of this session. You can follow along. So I encourage you to keep Spider open on your machines as well. And lastly, run the code on your end. There is nothing better than practice and more practice when it comes to programming. You cannot just learn it by looking at it. You have to do it yourself. Okay, I think I covered a little bit of that as well. Try to complete all problem sets. I said I will not be grading them, but it will help you a lot to learn. Though some of those are very interesting problems. We have 12 sessions, but only about 5 problem sets. And you will have about a week's time to do each of them. The first few will be very easy, but the ones after that will become a little bit advanced. If you follow everything during the course, you should be able to do it. You can collaborate with each other, but I encourage everyone to complete their own problems themselves so that they can get the most benefit out of this course. Lastly, it's not a university course, so there would not be any exams or quizzes, but there will be some in-class practice questions and opportunities. As I said, it's a very fast-paced course. The first session, for those of you who have already done programming or been a student of computer science before, this first lecture probably may seem a little bit boring, but it would be a good review. But for those who are beginning to learn, I think it would be good that we have a slow pace in the beginning, but it will become a little bit advanced. If you follow everything in every session, I think it should be good. Lastly, practice a lot. Try to redo everything that we do in terms of the coding examples that we will be doing. We will be switching to this spider window as we go along. And don't be afraid to try anything out. You won't be breaking your computer by just typing the Python commands. So don't worry about it. If anything happens, just restart your computer. It should be good, as we always do. So what is computer science? What is programming? At the very basic, it's just problem solving. All we do as a programmer is that we have problems and we solve them. How do we solve them? We solve them by creating an algorithm, writing a program, which may involve some looping, some iteration, maybe some recursion. What does that mean? And that knowledge will come as part of learning the Python programming language. So you have a problem to solve, and then you have the knowledge of a programming language. You know the concepts, how to implement it, and then you write that program or a set of programs, and those programming skills you develop over time, and eventually the result is that you solve a problem. But it's not always a mathematical problem. It could be any kind of logical problem, and your mindset of getting in the mindset of solving a problem is very interesting. And as a student, when I was beginning my bachelor's degree in computer science, it was very interesting to see how we changed the outlook on everything that we see around us. If you can convert every issue into a problem that you want to solve, eventually you will solve it. So here's a very, very good example of something that I did in the beginning of my, probably in the first semester in one of the courses similar to this, Introduction to Programming. We were told this problem. I don't know if any of you have already done this. Feel free to read, and if anyone has not done it already, I would like you to think about it and let me know how you can solve this problem. So there is a guy who goes to stay in a hotel, and he does not have money, but he has a silver chain that has 7 links in it. They are all connected. The owner of the hotel says, "I want rent every morning. So you have to pay me exactly 1 link from your silver chain every morning if you want to stay 7 nights." He does not want to change or destroy his chain, so he wants the minimum number of cuts that he can do so that he can later on fix it as well. So what is the minimum number of cuts? Because of course, when you cut one of the links, it will come out, and the ones on the left side will also be separate. Ones on the right side will also be separate. So does anyone have any suggestion where the cut should be made so that the person can pay exactly 1 link every morning for all 7 days? Think about it. It's a very interesting but simple problem to solve.
I guess 2 cuts.
2 cuts, and where would you do that?
1 and then 2. So one should have
So,
one link and the other one should have two. And the third one will have 4 links.
okay, so you will have 2 cuts so that you have a ring with 1, one with 2, and then with 4. Okay, so 2 cuts is your answer. Anyone can think of a better solution with just 1 cut? Okay, so you're very close. You mentioned you would have a result of 1, 2, and 4 links, right? 1 ring, 2 rings, and 4, with which you should be able to pay exactly 1 every morning, which is good. But you don't need to do 2 cuts for that. If you cut the 3rd ring, it will come out. The ones on the left are 2 and ones on the right are 4. So the answer is 1 cut, but resulting answer is same as yours, which is you will have 1, 2, and 4, a combination of which can represent any number. And note that these numbers 1, 2, and 4 are powers of 2, right? And with a combination of powers of 2, we can represent any number that we want. And this may come along as an underlying problem that you have to solve in many other computer science problems. So this was one of a very interesting problem. Okay, so um, we have data that we use in solving our algorithms or writing our programs. That data or any kind of knowledge that we use in programming, we represent it with data structures. What are data structures? Details of that will come on later, but some of them we will see in this lecture as well. Some of them are very basic or primitive. Some of them are scalar, which is just one value. Some of them are non-scalar, which is a combination or a collection of items like arrays and lists. We will look at that later on. Then there is a concept of iterations and recursions. In computation, you just don't want to write a 100-line long program. If you want to add 100 values, you can implement a loop that can do that for you. We will look at that later as well. Then these primitive scalar, non-scalar data types like integers and floats and an array of integers or a set of integers can be combined to create a little bit more complicated data type. For example, you want to represent a course that has a name, it has a link to its class, it has a schedule, it has some files. All of those could be combined into something called a class, which has all of that information, and there is one name for all of it, which is the class of a course, right? So abstraction, again, we will look at that in a lot more detail later on. When you write program, you don't want to write everything as one function or as one long, lengthy sequence of statements. You can modularize it so that you can reuse some of the components that you write. Organizing and modularizing is also a very important concept when it comes to programming. You can encapsulate your data into classes, and you can encapsulate your functionality into functions. And lastly, in the last few lectures, probably 10th or 11th or 12th, we will be looking at some of the important algorithms related to searching and sorting, and we will also look at what is their complexity, how do they behave when the size of the data or the input grows abnormally large, like into millions or hundreds of millions. All right. So what do computers do? They just perform calculations, but they do a lot of them, a billion probably per second. Recently, Google has announced a new computer or a chip that can perform something that could not be done in 100 years by the computers before it, right? NVIDIA is coming up with a very good chip technology as well. We hear a lot about that. But when computers were initially created, they still were far ahead of whatever was available at that time. So, and it's increasing and improving very rapidly. Secondly, computers can remember what it has already calculated. It can remember the results, it can remember the data, and not a small amount, like hundreds of gigabytes for every small computer or a phone that we carry today can remember results or keep the data for us. What kind of calculations? Some of them are built into the language. For example, the language that we use, Python, it knows how to add two numbers. It knows how to increase a number to some other power. So those are some of the calculations that are built into the language, but there are many other calculations or actions that you define as the programmer, and that's what we will learn as part of this course. So type of knowledge is when it comes to programming, there is some declarative knowledge, okay, which are some facts. For example, you define a number and you say, okay, X is equal to 5, okay, and Y is equal to 7. So these are two statements which is declarative knowledge. Just one question, when I switched to Spider, you were able to see this screen?
Yes,
I
all
believe
for
yes.
me.
Yeah. Okay. And then there is imperative knowledge, or something that we want to do with that declarations that we did, right? So I will come to the example on the screen, but let's see here. We have two variables called X and Y, and if I say X plus Y, the answer is 12, okay? So this is a calculation that we did based on these two declarations that we already had, okay? So in here, let's say someone will win a Google Cardboard, which are glasses. Nobody will, but let's say someone does. So out of you, so there is a recipe for making that happen. So all of you, let's say you signed up, you have a sequence number, like your registration number or something. So I open my IDE. I can use Python to choose who won something, and I will choose a random number between 1 and the last person. And then I find the number, who the number belongs to, and then that person would be the winner. How can we do this with Python? I can just think of that random number in my mind as well, but I can use Python. For example, there is a library called random, which gives us the ability to do anything related to randomization and random numbers. So I import that library and I say, okay, give me a number, I believe it's called randint, between 1 and 15. Okay, if we are 15 people in this group, and it says, okay, the 7th number is the winner. Now this is a kind of calculation or an action that Python provides us by default as part of this random library. And between 1 and 15, it said seventh person. Since this is a random integer, if I run it once again, I will get a different number, 13. And if I keep on doing that, every time I will get a different number. They can repeat, of course, because there is a calculation behind it. And nothing in computers is actually random. It's all based on some calculation, and we can figure that out if we want. But it's not a topic for today. We will come to that later on. All right. Okay. Here's another example of a kind of numerical calculation. Square root of a number x is y, so that y times y is equal to x. All right. So what's the recipe for guessing or deducing, actually calculating that number? So let's say that number was 16. Our recipe or steps or algorithm would be that we start with a guess, let's call it G. And if G times G is close enough to X, we should stop and say that G is the answer. If it's not close enough, we make a new guess by averaging G and X divided by G. That will give us a new number, which we will use as a new estimate, and then repeat the process until we get very close to a number that we can say, okay, now the error between our result and 16 is too close, and we can stop calculating. Okay, although there is a function available by Python which can exactly give us that number, but suppose if you don't have that, this is the process that you will use. Okay, we start with 3. 3 times 3 is 9. We say no, it's not close enough to 16. So 16 divided by 3 is X by G, and the average of that and the previous guess is 4.17. We use that as the new guess here. Now the square of 4.17 or 4.17 times 4.17 is 17.36. It's still not close enough. We do another estimate, make the average, and then 4.0035 comes back as the answer. It gives us 16.0277 as the answer, which we can say, okay, it's close enough. If you still don't think, you can do another pass, and that will get even closer to 16.0 by using 4.000002 as the next guess. So this is our algorithm, very simple algorithm to calculate square root of a number. All right, so what was that? It was a sequence of simple steps that we can do to perform a task, and then a flow of control between those steps. We may be just doing them in sequence. There may be logic within your program to do them, to jump around between those steps. And we will look at those a little bit later in the course, probably not in this session. But there are options to make your flow of control jump around between your statements and then eventually do what you actually want to do. And then you should be able to, you don't want your program or algorithm to run infinitely. You need somewhere within your program to identify when to stop. So that would mean that you have an answer. 1 plus 2 plus 3 is a statement, which is an algorithm, a very simple one, and it gives you an answer of 6. All right. Okay. So what do computers do for us in terms of recipes or algorithms or problem solving? There are some fixed program computers. For example, a calculator, it has some buttons on it, and it can only do what is already defined on it. A stored program computer, or the one which we are using today, or where we can define our statements like this. We can store them in files. Let me see if I can open the code for this lecture, which was shared with you. This is a stored program. It has multiple statements. I can run one of them, or a group of them, or all of them. It will give me some results. So these are stored program computers, where we define what it wants to do, and our definition of what we are asking it to do is the programming that we want to do. All right, moving on, some very basic architecture of the computer. It has some memory. It has an ALU called the arithmetic logic unit, which does the actual operations. There is a control unit which uses our definition of the program stored in the memory to run those set of statements one by one. It uses the ALU for the calculations or other operations. It gets some input from the user. It also gives the output to the user, and all of that is done by this control unit. Don't want to go into too much detail. It's not a architecture course. Our stored program computer, there is a set of instructions that we define. They're stored in the computer. They are built using whatever the language provides us, so that it can understand it. It could be a set of primitive instructions. It could be some mathematical, arithmetic, or logic statements. If this is equal to that, if not, then do this. There may be simple tests of equality check or greater than, less than kind of checks. We can move data around between variables or from one place to another. We can transform it. And the interpreter, which is the Python interpreter here, if I write something which it does not understand, it will give me an error. I will say, okay, 5 plus 5. It does not have an answer because I cannot add a string or a word with an integer. I can probably add 2 words. It will give me a new word with everything in between both of them. I can add 2 integers, but I cannot add one type to another. It won't understand it. But this interpreter will go through those statements, and it will do something, whatever I want it to do, and it will stop when those are finished. What are these primitive statements that I mentioned? Alan Turing, who is said to be the inventor of the modern computer, he said anything can be done using 6 primitives. Primitives are the very basic actions that the computer already knows how to do. And those 6 primitives back in the, I believe it was the 50s or 40s maybe. Those were six actions. Read, move left, move right, read, write, scan, or get an input or something, and then do nothing. With those 6 actions, you probably can do anything, could have done anything at that time. But now these programming languages have a very large set of primitive statements. For example, we just saw the example of using the random library and just generating a random number without going into the detail of how random numbers are generated. So these new there are these new primitives or actions available by these programming languages that we can do. And anything that you can do in one programming language, you can do it in any other programming language, because they're all based on these primitive actions. Just the syntax or the way you write the code will be different. Excuse me. So just to recap, programming language gives you a set of primitive operations. Expressions are complex, but something that a programming language can understand. For example, an expression that I just wrote, 5 plus 6, is an expression. It has a meaning, and it gives you an answer. Right? What is the difference between English and any other programming language? We call them both languages. So English has a dictionary. It has a lot of words. Not all of them combined together make any meaning, but there is a specific grammar behind it, so that when you have a noun, verb, noun kind of combination of words, it has a meaning. Similarly, in any programming language, there are many different words that it understands. There may be data types, there may be operators, and other reserved words, but they will have a meaning only when they are written in a certain sequence. What is that sequence? That is the syntax of that language. In English, for example, if you say cat, dog, boy, they're right words. They all belong to the English language, but they don't make any sense because they are all three of them are nouns. But if you say cat hugs boy, it's syntactically valid. It still might not make a lot of sense, but it sounds a little bit okay because it's a noun, verb, and a noun. What happens in a programming language? if you say hi 5, just like this example I wrote here, 5 plus 5, or exactly following this, hi 5, invalid syntax. It does not do what to do with it because it does not make any sense. But if I say 3.2 times 5, it makes a lot of sense. It says multiply these two numbers, answer is 16. All right. So what we write in any language has to make sense for or based on the rules of that language, and that is called the syntax of that language. Some more examples. It may still be syntactically correct. For example, I are hungry is still does not sound okay, but it's a noun, verb, and a noun. It's syntactically valid, but it does not make sense. So there is a semantic error here. So what happens when I look at a programming language? 3.2 times 5, we saw it's syntactically valid and it's semantically valid as well. But 3 plus high, it's one value, an operator, and another value, but those values don't match with each other in their data type. So that's still an error. All right, it's syntactically okay, but there is a semantic error here. So semantics is the meaning associated with any collection of values and symbols or operators between them. For example, in English, a statement can have more than one meanings. Flying planes can be dangerous. Is it, if you are flying a plane, it can be dangerous, or planes that are flying can be dangerous? We don't know because it does not explain here. But in a programming language, if you write a statement which is syntactically correct and semantically correct, there can be only one meaning that can come out of it and one result that can come out of it. That's the difference between a spoken language and a programming language. Okay. So what happens when you write a program? There are some syntactic errors easily caught because your language will tell you what's wrong. Can only concatenate string but not int to string. It's invalid syntax. It will tell you exactly what's gone wrong, so they're easily caught. But then there are some semantic errors. Some languages can check for these. Some might not catch them depending on their complexity, but the behavior will be very unpredictable. There may be instances where you wrote a piece of code which is correct. There are no semantic errors, there are no syntax errors, but it's still not doing what you intended it to do. So what went wrong there? The program might crash, it might run forever, or gives you a different answer, and you would never know what went wrong. So catching them may be a little bit hard, and you will find out about that once you start programming. So programs, they are a sequence of definitions and commands. Definitions like declaring some variable, and commands like doing some operations on them. These commands, they tell the Python interpreter to do something like add two numbers or make a square or a square root. They can be, we can write them directly here in the shell. This is the shell, this is the program, this is stored in a file, this is something that we are just doing right away. You can have files stored on your hard disk, and these will be your programs. And problem set 0, the one which will just release after this class, will introduce you to them. Okay, we talked about some data types in the beginning. I said we will come back to this. Scalar objects. Scalar objects are variable types that have an individual value or just one value. For example, an integer. Integer is a data type that can represent numbers, which are whole numbers. It can be positive or negative. Then we have a data type called float, which can represent real numbers, 3.27, for example. We also have a data type called bool. Those you have done any kind of programming in any other language before, you would know this is a Boolean variable data type that has only two values, true and false, and they are very important for us in making during decision making in programming and in developing our logic to solve a problem. None type is a special variable, and it has only one value called none. When something does not have a value, or if there is a function that does not return you something, or where you are supposed to return something and you don't, the return type will be none. Sometimes it looks like a very small thing, but a lot of time it comes in very handy to use it in our expressions and logical operations. If you don't know what the type of a specific variable is, you can find it out by using the type command. For example, I say, you remember I defined x and y in the beginning. If I say, what is the type of x? It's an integer. I can say now z is equal to 2.0. Since I have given it a real number, not an integer, and I ask what the type of z is, it will say it's a float. All right. Okay. You can convert objects of different types between each other as a different type. For example, if I say float of an integer, it will return me a float value of the same integer value. And I can also convert an integer, a float to integer. It will truncate it and give me back the integer within that float value. We can print to the console. You see, we saw a lot of examples here. Whatever I ask it to do, it does and gives me an output. But this it's 77th statement that I have run, which I inputted 3 plus 5, and 77 out was 8. But if I say print 3 plus 5, the output seems a little bit different. It did not say out here. So this is not something which is shown if I write this as part of my code in my program in a file here. It would calculate 3.5, but 8 it will keep to itself. Since we are in the shell, it is showing it to me. But unless I say print 3 plus 5, this 8 is something which is actually shown to the user. And you will learn that as you do your first assignment. All right. So it said in 3 plus 2 out 5. This is calculation it did. In here, it still did the calculation, but I also asked it to print it for me. So it printed 5 as part of the output here. So 3 plus 5 is 8. Okay, moving ahead. We can combine objects and operators to form expressions, just like we mentioned in English. There is a certain structure to sentences. There should be a noun, verb, noun. So in programming languages, we have an object, an operator, and an object. What is an object? Objects are those variables that we just talked about, and operators could be of very many different kinds. For example, I plus j gives us the sum. If both are ints, the result would be int. I minus j gives the difference. Star is the product, and slash / is the division. There are 2 more in the bottom. If you write I%j, it gives you the remainder when I is divided by j. All right. So if I divide, let's say, 10 divided by 3 is 3.33. If I say 10% 3, it says 1 because 1 is the remainder of 3 times 3. So a full division, the highest whole number division between 10 and 3 is 9, and the remainder would still be 1. All right. So that's a very useful operator that we use in many places in programming. If you write 2 stars, that means you want to raise something to that power. 2 star 3 is 8, which is 2 raised to the power 3. So some very simple operators. So these are some simple operators, and we can use exactly as we do in algebra. We can use parentheses to identify which ones to do first. Sometimes it comes in handy, and many logical errors in our program that cannot be caught by the interpreter are because of how it is doing the calculation. So we have to be a little bit careful about that. Precedence of operations within the language. Okay, we are approaching the close time and also to the end of this session. Let's say we have now we did the operations directly here, okay, but let's see how we can do this by defining variables and storing them in memory and then playing around with them. Okay, so I say pi is equal to 3.14159, and pi approximate is another variable to which I gave the value of 22 divided by 7. Okay, and I can use, once I define them, I can use them for any of the future calculation that I want, as long as they are still in the memory. Okay, so we don't want to carry around this value everywhere with us. We can store it in a variable and then use it in future calculations that we want. All right. So I say pi is equal to, I'm now looking at the left-hand side where I have this lecture 1 code that was given to you. Pi is equal to 3.14159. Radius is 2.2. This hash mark here tells us that this line is a comment. It would not do anything. I can write anything here. And then I'm calculating the area using this formula called pi r square by using the values of these 2 variables that I just defined. Okay. If I run these 3 lines, what will happen? It will define a variable called pi, it will define a variable called radius, and it will define a variable called area, and will calculate it using the values of pi and radius. So let's see, I'm using this this icon called I here, which will run the selection that I have selected. Okay, it showed me the code here in 82 that pi is this, radius is this, there is a comment line, and area is this. So now area has been calculated, but I haven't printed it yet. Okay, this last statement I did not include in my selection. I can write it here. Okay, show me what the area is, or which is 15.20 something. Or I can, when I was selecting the statements, I could have selected that as part of my selection and then run the code. It would have given me this answer here, which wasn't here in the previous run. Okay. Now, so that's one example, but let's say we increment the radius a bit. Okay. So we say pi is equal to 3.14159, and radius is equal to 2.2, and area is equal to pi times square of radius. Okay, and then print the area. Okay, 15.205. And then I want to increase radius is equal to radius plus 1. And then I print the area. Area is still same. What happened here? Can anyone tell me? I increased the radius, but when I printed the area, it's still same. So the issue is the statement that I ran for calculating the area was using the radius which was available to it at that time. That value of 15.205 was bound to the variable of area. It is still bound to the variable of area at this time. Radius is updated, but I have not recalculated area based on the new radius. If I run this statement once again, now that I have updated radius, okay, and I print area, it will be the new area. So this sequence of what you are doing, what you want to do is important. You're not solving for x. It's not that both sides have a set of expressions on the left. There are a set of expressions on the right, and they are equal as we do in algebraic theorem solving or any kind of algebra problems. Everything that is on the right is calculated and assigned to the variable on the left. Your variable is always on the left and your calculation is always on the right in programming syntax. So we defined pi, we defined radius, we calculated the area, and then we updated radius by 1. If we want this new value of radius to be used in area, we have to recalculate the area with that formula once again, and that would solve our problem of this updated value of area like I did here. And this slide actually is explaining the same thing. Pi was bound to this value of 3.14, radius was bound to 2.2, and then area was calculated to be 15 point something. But then we updated radius to 3.2. What happened is that 2.2 is still somewhere in the memory, but that its link or its binding to the word radius was lost. And radius now points to the value 3.2. If I want the new area based on this new radius, I just have to rerun this command here, and it will give me the new area based on the new radius. Meanwhile, what happens to 2.2? It's still there in the memory. What programming languages do is they run a garbage collector every now and then. And once that's done, all the unbound or lost handles kind of places in the memory, they get collected and they get sent to the trash. As part of our program, we just have to keep on updating our values based on whatever we want to do. All right, I believe this is the end of this session. I think we did the example that was included in the code. Yeah, there's nothing very special here. The lecture code and the problem files in future, they will get a little bit more complicated but for this lecture, it was a very introductory lecture. I hope you guys have understood a little bit of what computers can do for us and what we can ask it to do. As I said in the beginning, for those who are already doing programming in other languages, that might be a little bit boring or maybe just a refresher. But as we move forward, things will get a little bit more interesting and more complicated. So before we finish, if anyone has any questions, we have some time to answer those. Oh, I have some messages in the chat. Sorry. I have a question about using Spider. Okay. So let's say you have just opened it. Let's close everything. So when you open it, you have 3 windows. you have this area on the left side is for your files. And if you don't have open anything, it will open an untitled file for you. On the right, there are two areas. One is an explorer where you can move around in your on your drive and see which folder you want to go in. And here at the bottom right side, there is the shell where I can run some commands directly. Okay. There was another file I think provided to you guys. I'm not sure if I did that. It was called package test. Okay, so if I open this has a long list of some statements, for example, right? So I double clicked on a file on the right side. It opened up in here, and if I run this, it would do something. Okay. In the shell, it told me that it has run this file located on this very long path. Okay. And it did something. What did it do? I can see in the variable explorer here. It has a lot of definitions here. Area, pi, radius, XY, all of these I did in the beginning. They are still here. But there are two new items here called data, which we did not do during the class, but they are part of this file execution on the left. Data is this long array that it defined. It's showing me its value, and the size is 398. It contains 398 values. Okay. And then at the end, it said y data is empty, but then it's doing something with y data. It's in order to plot something. So it's using PyLab to plot a graph based on the data defined in this array here. We don't need to go into the details of that because we will look at that arrays and those kind of data structures and their usage later on. But it created data. It had data as present in here. It created the y data array, and then it plotted something. There is a tab here called plots. If I click on it, it will show me the result of that plot. And this was done by using this library called PyLab. So it told PyLab to plot the y data, which is here. You can see that here in blue. It gave it a title called Earthquake Magnitude in Japan from this to this. And X label is time, Y label is magnitude, and then show it. So that's why we are seeing it here in the plots tab. So this is again one of those libraries. For example, I imported random in the beginning. In here, it imported NumPy and PyLab, and it's using PyLab to do this plotting. So if you have any amount of data that you want to plot, you can use Python very easily to do that plotting. So you have your files, you have your variables. Here's the shell where we can run commands individually, and on the left side you have files where you can write your code and then execute that file or a selection of some statements within that file using these options here. It will still show you the results on the shell on the bottom right side. Okay, so that's some introduction about Spider. Any other questions? All right. Okay, if there are no other questions, we will finish the session here. I will share problem set 0 in email with all of you. If all of you received email, that means I have your email addresses. If you don't, send me a message, private message in WhatsApp, and then I will add it in there. Our next session is on Wednesday evening. I will share a separate link for the class for that later on. Okay, so thank you everyone. Okay, thank you everyone. Have a nice weekend, rest of the weekend, and nice week. Bye.